stress strain curve. Okay, in this mechanical behavior connective tissue, if we take connective tissue, here we have two properties: viscoelasticity one property, second property mechanical behavior. In this mechanical behavior we saw what is stress, we saw stress and strain, we saw, then we saw what is the failure point, these 3 points we saw. Okay, so in these 3 points, related in these 3 points we saw load and deformation curve. So this point we saw. So now we'll see what is stress strain curve. What is stress and strain curve? We know what is stress is nothing but force applied on the area or cross section of the area, that is stress. Strain equals to the length of the structure, initially length of the structure divided by change in the length of the structure. So this is strain. Okay, now we will see what is this stress strain curve. Suppose now we are going to see stress strain curve for the ligament or maybe tendon. So one structure is there. Suppose one ligament or tendon. How the stress strain curve will look? Okay. Suppose here I am taking stress. Here I am taking the stress. Here it is strain. Here it is strain. So it is going to represent the how much stress we are giving. It is going to represent the how the strain is happening in that ligament or tendon. So if we see here, if we apply stress to the ligament, here I am keeping this point like 0. Okay, if we apply stress to the ligament, 0 to 1 range, here I am giving point like here. So this is one range in the starting point. If you give stress at the initial range, here the tendon or ligament will deform, deformation will happen. So here 0 to a, this point is nothing but toe region. What it means, here we need less stress. To elongate the, here we need less stress to stretch the object, stretch the ligament or tendon. Now from point A to B, so here point A to B, this region we can say like elastic region. So here point A to B, here what it means, here this, if we want to elongate this structure, here we need more stress, so that in the initial 0 to A, here with less stress we can elongate the structure. In this elastic range A to B, here we need more stress, to elongate this structure, so that here this straight line A to B is directly proportional to the strain. So if we give more strain, the tissue will elongate. After removing of load here, the tissue can come back to normal position. The tissue can come back to original position, so that it is the elastic region. So from here, so this is the point C. This we can say the middle portion, the middle B to C. We can say it's a plastic region. What is this plastic region means? Here if you give load, stress, nothing but stress, if you give stress in this point, what will happen? The tissue will go for deformation. After removal of stress, the tissue will not come back to normal original structure. That is called a plastic region. So B to C is the plastic region. Here deformation is permanent. So that tissue will not come back to the normal original structure. That is plastic region. Now from C to D, so here this is the ultimate failure point. What it means, from C, if already this is the plastic region, here tissue will go for deformation. The deformation will not come back to original structure. Even though it is not coming to original structure, still if we are applying load to the structure, then it will go for ultimate failure point, so that here the tissue will tear, nothing but rupture. So that is ultimate failure point. So this is the points. The C to D is the ultimate failure point. point. This is about the stress and strain of the ligament or maybe tendon ligament. Suppose here one bone is there, here one more bone is there. Between these two will be having one ligament. Between will be having one ligament. According to the stress strain curve, see stress strain, stress and strain. So here we will be having 0 to A is the toe region. 0 to A is the toe region. Toe region. A to B is the elastic region. Elastic region. And B to C. B to C is the plastic region. B to C is the plastic region. Plastic region. C to D is the failure point. Failure point. Ultimate failure point. Now we'll see what it is, how it is related to ligaments and tendons. Here we are taking example as ligament. Example as ligament. 0 to 8 is the toe region. What this region is saying, here we need less stress to create the deformation. Suppose if we are giving, this is femur, this is tibia. Suppose if we tie 2 kg weight to the tibia, the length of the ligament, nothing but deformation will happen with less weight in this toe region. A to B is the elastic region. So here the weight will be more. 5 to maybe 10 kg. 5 to 10 kg weight we need to elongate this ligament, that is elastic region. So that's why here A to B elastic region, it is directly proportional to the load. It is directly proportional to load or resistance. That's the A to B point. And B to C plastic region. So here load will be same. After elongation, the length of ligament will increase. That is elastic region. Okay. Then B to C, if the load is same, it is still applying on the ligament. If it is still applying on the ligament, then from elastic region, the ligament will enter into plastic region. What it means, after removing of this load, if you remove this load, the ligament will not go back to normal position. That is nothing but plastic region. Then C to D is the failure point. So already if it is in plastic region, still the weight is applying on the object, applying on the ligament, so that at one point of time the ligament will tear. That is nothing but failure point of the ligament. Okay, that's a failure point of the ligament. Now we'll see one special point. If the failure is happening, it is going to create the rupture. At ligament. Okay, suppose this is one bone, here ligament is there, this is also one more bone. Okay, ligament is there. If the rupture, where the rupture will happen, usually rupture will happen at the center. If the rupture is happening through the bone, with the bone, if it is happening, then we will say it as avulsion fracture of bone. So here the tendon ligament will go like this. When it is going to rupture, that time it is going to rupture the some part of the bone. So that's why avulsion fracture of the bone. So this is about stress strain curves. Okay. Like overall, like summary, if we see properties of connective tissue, here we will be having viscoelasticity property first. Second one will be having mechanical behavior. In this we will see what is viscosity, what is elasticity. Then these materials will go for two properties, time dependent property and rate dependent property. In this time dependent property we will see what is creep. After that we will see what is stress relaxation. This rate dependent property will see what is hysteresis in mechanical behavior. So here we are going to see the what is stress, what is strain, what is failure point. After that, here we are going to see two curves. One is load deformation curve. Second point we will see stress and strain curve. So this is about the properties of connective tissue. Clear?